have one cyclone, some may 3, 4, 5, 6, 7. So they're still doing the same thing. They're separating the air by spitting the particles out. The air then comes out of the top of the cyclone, goes into the bottom of the bag house. This particular model has a tube sheet in it, but the tube sheet would be where the bags or the cartridge filters would be. You can see, can you see it from back there? Then the air would go through the bags, out the tube sheet, through a strainer of some sort, depending on the manufacturer, through the blower, then out the silencer. All air machines have basically the same air path. It's just a matter of how one guy does it one way and another guy does it another way. In the filtration system, I don't have anything to illustrate the bag house how it works, but basically what happens is the dust particles collect on the bag, they start to blind the bag, so to speak, then the pulsation of air blows the dust free, and it falls in the bottom of the bag house. Some of you guys may not be in the business, but if you looked around, they look fairly complicated, all the machines. You see, they're really not. They're all basically the same thing. So what we want to do is talk about the cyclone part of the filtration system and how that works. What I'm going to do is start off with just this jar. This cyclone, I've got a separate cyclone here so you can see it better. It would be inside this chamber here. You can barely see the cone. We had some dust in it yesterday, but it's the same cone here that you see there, and this is a cyclone. But I want to just give you an illustration of how that works. We're going to start off, I need that end of that hose there, Kevin. We're going to start off and we're going to explain a couple of things before we actually run the cyclone, but we're going to hook it up. I've got a little short hose here. Now there's one down there. Give me that shorter one. I don't have much room to work up here. Just take it out of that plastic there. There you go. Thank you very much. And what we're going to do is I'm just going to fire it off first to let you see where the airflow goes. The air comes in here, goes in a cyclone, spins the material out, comes out of the top center of the cyclone, then it just goes into this jar and out. I've got a balloon in here to illustrate that the airflow is flying through the machine. So just turn it on for a second, Kevin. You see what's going on? Watch this. Notice how the balloon stopped moving? It's not moving just for the vibration. So you turn it off. Again, the air comes in, spins out, clean air comes out into the jar, then to the little shop vac. Now, what is a cyclone? How does it work? What does it do? Where does that come from? Okay. I'm going to walk over here and do a little illustration of something. This is going to be the United States. Here, California is not. I got California out of scale to Texas. Baja over here, blah, blah. This is Texas right over here. You've heard it on the news or seen on the television where people are talking about, or the weather people are talking about a hurricane that's in the Gulf of Mexico. It's headed towards Houston or New Orleans. And you'll always see the aerial photographs of a hurricane. It looks something like that. The eye would be very, very small. And in this hurricane, the lowest pressure is right here in the eye of this hurricane. And sometimes you hear them talking about this thing is so many millibars, and I mean it's really a low pressure. We're really going to have a bad hurricane because the lower this pressure becomes, the more intense the air circulation becomes. Also, one of the phenomena that occurs is the moisture droplets are spun out of the center or the eye of the hurricane by the circulation of it. You also got cool air and whatever going down through the center of it. But actually, it actually clears this air. You've heard people talking or maybe seen after a hurricane, I was standing on the coast or I was in my home and it was this pandemonium, and a few minutes later it was dead calm. Dead calm, no movement of air. You could look up, you could see the stars at night, or you could see the sunshine. It's just crystal clear, no movement. But an hour later, all hell broke loose. You know, what happens is it's going one direction, you're feeling the wind one direction, as the eye passes over, it catches in the other direction. That's the same thing we're doing in a cyclone. And I wonder why they're called cyclones. Well, south of the equator, hurricanes are called cyclones. And basically what we do with a cyclone is we load material with air in here. You can't see this one as well as you can see that one. It spins the material out, then the clean air comes out just like it would come out of the eye of this hurricane to the vacuum source or whatever's creating that low pressure. And in this case, it's a roots blower. So what I want to do is we're going to illustrate how this actually works by turning the shop back on. And I used some talcum powder and perlite yesterday, and people just couldn't see it. So I'm going to use some coffee, which I normally do use. We had to buy some coffee today. So you can actually see what's happening. Now, what I want to do is just ask Kevin to turn it on, watch the material come in and spin out and fall down here. On a cyclone, one second. On a cyclone, you have to have dead air space. In other words, if I tried to run this cyclone like this, what happens? The air comes in here and it comes in here. It doesn't do what I want it to do. So what I have to do is create a dead air space, and that's what I do with this jar. And when he turns the shop back on, it creates enough vacuum that it pulls this down and seals it right here. So now I have the air going where I want to, spinning the direction I want to, and taking the material out of the airstream. So just turn it on, Kevin. Let's see what happens. Can you see that back there, what's going on? You notice there's not one speck of coffee over here on this side. If you look up close enough, you can see it's really spinning through here. Turn it off. That's just we'll do it one more time real fast so maybe you can see a little bit better. Okay, turn it back on. Okay. It sticks on the side of it. I'm going to dump this out. The coffee is relatively easy to separate from an airstream. But in air movers, we've got to deal with something a little bit finer than coffee. We've got to deal with fine materials, sometimes down as small as 10 microns. And I have some material that's approximately 10 microns. This is just Johnson's baby powder. Baby powder is talc, and talc is about 10 microns. I mean, you would agree that that's fairly light stuff there, isn't it? This becomes a little bit more difficult to separate with a cyclone. It will work, but everything has to be perfect in a cyclone. I'm just going to dump some of this down here. I'm going to load it up. What I want you to do is watch. We're going to do it a couple of times. As the material comes in, you'll see this part of the cyclone turn white. This will turn white. But what I want you to notice is how clear the air is going over where this balloon is. And remember, all of the air that comes in here ultimately winds up here. It has to go through the cyclone, it has to go through this jar, period. So let's just watch what happens. Okay. You notice how clean the air stayed over here? But this cyclone seals almost perfectly. I have a little leak in it where it doesn't quite seal up. So what happens if I have a leak? And I'm going to demonstrate if you have a little bit greater leak in a second. Remember, the material is coming in the cyclone here, spinning out, spinning around, clear air. Well, you can see where the coffee and the talcum powder spun around the cyclone, and then the clear air comes out right here. But what happens if everything's not so perfect? I want to do something here that shows you what happens. You hear people talking about, oh, he's got a lot of carryover into his bag house, and he's got dust in the bag house, and his bag house is full. And that happens. It happens to all air machines. It happens to guzzlers. It happens to all of them. And it's usually because the people don't take care or maintain the sealing system. You've got gaskets and seals on any brand of machine, including ours. And if you don't maintain all those gaskets and seals and keep those from leaking, you're going to have a problem with cyclone because it's not going to do what it's designed to do. The air has to be equal on both sides of the cyclone, in here and in this jar. Any leaks that develops will cause the cyclone to have air come in through here. In this case, if it leaks here, it comes through here, it disturbs the eye of my hurricane or cyclone, and no longer becomes an effective filtration tube. So what I'm going to do now, I want you to watch this jar as I load the material. I'm going to load the material, but I'm going to kind of pinch in on this cyclone right here. and create a leak so that the pressure is not equal any longer. The air is going to go in here, it's going to go through the eye or the cone of the cyclone and disturb my cyclonic filtration. And as soon as I do that, watch what happens over here. Okay, we'll start off good. Right, here we go. Can you see what happened? It's still working as a cyclone, but not very efficiently, is it? Okay. You see what happened to me? All it took was a little leak to imbalance that pressure. Here it is. This would represent the bag house on any machine. So here's all the material going to the bag house. Not all of it. I mean, the lion's share of it does go in here, but there's enough of it gets in the bag house to deal you some misery. And it happens to all of us. I mean, you've got to maintain the seals. On the ACE, as an example, we have a clean out. This is just a model. If you go over to our booth and look, there's a door right here that's used to clean it out. If that seal's leaking, I'm sorry, I'm on the wrong side. If that seal's leaking right here, we have the same effect that we had whenever I squeeze this plastic in on the little jar, and air goes in and material goes through the eye of the cyclone. If I have a gasket leaking back here, same thing would happen. This is a dump tube right here. When it dumps the bag house out. So if I had a gasket leaking on this little door that's normally on here, air would go in here, go through the eye, and disturb it, I would get it in my bag house. So all those gaskets and seals are important that they be maintained. One of the problems you see is, and gaskets and seals give themselves up over a period of time. You go by, you see a guy's got duct tape. He's got doors taped up because the gasket's leaking, and he's leaking air. He said, well, that's not hurting me. I've got more air than I need anyway. That's not hurting me as far as the suction, and it's not. But where it does hurt him is it's leaking, and it's messing up his cyclone, and it's stopping his bag house up. So you have to maintain these on any machine. Don't let anybody tell you any different. All machines have that inherent problem. You have to keep everything tight on the dead air side of a cyclone. Okay, I want to take this, kind of get it out of our way here a second. Yeah, just got about 20 minutes. Okay, get these out of my way. We want to talk about a different type cyclone for a second. Guzzler, as well as several manufacturers, make a cyclone that is used for loading drums, roll-off containers, super sacks, or something other than loading the hopper. What they do is they take the air out of the cyclone. It would, in our case, it would be here or mounted here, and they swing it out where they can hold it over a drum or a container and load material. I want to use coffee for this because it looks a little better. You can see it better. It'll take me a second to set that up. There's nothing I use in this class that will harm anybody. We can make coffee with this. We can put this on your rear end, make you hot dogs, whatever. So I don't want anybody going out here and say, I got sick. That Guzzler guy was up there with all kind of chemicals. Everything's edible here except the talcum powder. So what we do is we have this cyclone that's used to load other objects. I'll have to get on the board to make an illustration or a drawing. In fact, I'll just take this with me as I do it. There it is right there. Can't remember to bring my razor. Let me clean this off. Okay, what we have is, I'm going to kind of draw a cross-sectional view of this cyclone as best as I can. What we have is a cyclone that we use to load material in. Remember, we have to have this dead air space, like I had with the jar up there. Well, this one right now doesn't have a dead air space. In a real cyclone, what we have is a valve here and a valve here. And they're set up on a timer sequence relay system that opens and closes the valves automatically through a pot that you can adjust the time that they open and close in accordance to the material you might be working with. So when we start off, we'll be loading material in. We'll be loading material in, taking air out here, material spinning in and falling down. Start off with this valve open. The material falls into what we call a Dutchman. This is a Dutchman part of a cyclone. Once it falls in there, this valve will close. This valve will open, and it would fall into a drum or container or sack or whatever. Now what have we done? We've maintained our vacuum the whole time. We're continuing to load at the same time this is working. Then this valve will close, this valve will open, and in the meantime there's some little bit of material building up in the cyclone here. Well, as soon as this opens, it falls down in here. Then as soon as it does that, this one will close and this one will open. There will always be one of those valves closed all the time. Now occasionally I'll have a guy that's a little bit smarter than us that gets in there and starts to tinker around with the timers and the relays and what have you. And he'll get it screwed up some way or another that he gets two valves open at once. And I've had an incident where a guy did that, had a super sack. You know what a super sack is? It's a big old sack. And he calls me, he said it looked like a snake swallowed its tongue. The sack is all up inside the cyclone. Well, you go out there and they've got tape all over micro switches and everything trying to change the timing when all you have to do is turn a relay, you know, and he's got the thing jammed in there. So as long as these are both, or one of them's open or one of them's closed all the time, that won't happen. And they do have to be maintained so that there's a seat that it seats on. You can't run abrasives through and run it forever without maintaining it. I'm just going to do a little demonstration quickly of this and show you how it works. Now, I don't have the valve. I didn't go to the trouble when I made these little things myself in my garage, by the way, to build a valve system on it, and it'd get pretty complicated. But what I'm going to do is use my hand to act like the valve on the bottom, and then you're going to see the material load in it, and then I'll have him shut it off, and I'll take my hand off after the vacuum starts and it'll drop out. Okay, let's go. Okay. You can still see the stuff, even at low airflows you can see it spinning. At that point this valve would open, it would fall out, and remember this valve is closed now while we're doing that. Okay, once that's all out, the coffee kind of bridges on me. Go ahead and start it on again. Okay. And you can see how it did it. It becomes a continuous type operation. So that's what we call a remote swing out or a loading type cyclone. It's not used in the filtration system. It's actually used to load a container, whereas this cyclone is used in the filtration system. We're going to do a little demonstration here of how the air flows through the whole machine. And again, this would be all machines similar. Just take a second. We're going to set this up right here. Let's put this right here. Where's my duct tape? You cannot own an air mover without duct tape.